Hello, Mr. and Mr. Ryan, right? Yeah. Okay, so what did we learn yesterday?
We learned about apple catching game.
Yeah. Okay, so now and look, this is the source code. Yeah, let's go review this a little bit. Yeah, we can press.
So
Yeah. You see, we can press left and right. Yeah, so this is move left, and then we set the button A to move left. This is the game over. Yeah, I changed it a little bit. Look, I call this if not game is running, we just return. Yeah, okay. If not game is running, we just don't do anything with the control. Reset the game. Yeah, reset the game. Reset the game. So when we press the A and B together, if the apple has not fallen on the ground, we just ignore it. Yeah, just to avoid people making mistake by pressing the A and B together when the apple is still falling, right? Yeah, that's what it means. And when we reset the game, it sets the score to 0, sets the apple to a random position, yeah, in the top row, and resume the game. And then A, B, this is reset. Move right, okay, we love it. Move right. Get current delay, the faster, higher score, less delay, faster apple falling speed, yeah? Got it? Okay, so this is the main logic. So now today we're going to let the computer play it, right? So we don't want to play it, yeah? We let the computer play.
So how? Never literally loses.
Yeah. So how do we make the computer play? What's your strategy? If you're a computer, what do you play? How do you play?
Like.
So first of all, we just
if you just go for like the
quickest, the shortest path, yeah. Shortest path, yeah.
Like if you're there, and if you're here, and then the apple's there, and like.
Okay, yeah.
And
so basically, yeah, the apple is here, the apple is here, and this is your bow. Yeah, this is the bow. So if it's on the left, you just go left. Yeah, all right. And if the apple is here, and then the bow is there, if the apple is on the right, just go right. Yeah. This is one strategy, the most simplest one. Just towards it. And just remember that we can wrap the bow, right? So what does it mean? It means that look, if we let's place A and B. If we go left, and you'll go from the right. If you go right from to the rightmost place, you'll wrap up to the left. Yeah. So we can actually add these to the check. So first of all, let's say define computer. Okay, computer play. Okay, this is the function we're going to call, and then we just put it here. Yeah. Okay. Let computer plays. Okay. So now it does nothing, but we can do this. Yeah. So this is actually kind of the most simplest artificial intelligence. Yeah. Artificial intelligence. Yeah. It's called decision rules. If left is shorter, we go to the left. If right is shorter, we go to the right. Right? Yeah. So decision rules, decision tree is basically something like, okay, if something, then do something. A prediction. If something condition, and do something. For example, like if today is April, right? Someday in April, right? Then tomorrow.
Go for barbecue.
That's right. Yeah, something like that. Yeah. This is if
last
else.
year we had a barbecue.
Yeah, we can do it this year as well. So barbecue. So then prediction. Yeah, we're going to do the barbecue.
Gonna play games for the whole day.
Yeah. Okay. Something like that. Okay. So now look here. Okay. But first of all, if it's the same, look the position, like this x apple, right? Apple x. Yeah. The horizontal position equals the apple dot x. Yeah. X. Okay. And then if first of all we have to check. Look, if the bar dot x equals apple x, right? So if the bar is right after the apple, below the apple, so what should we do? What should we do in this case? Look, if apple is here, and then you are just right below it, what should we do?
You just do nothing.
We're done. Do nothing, yeah? Just do nothing. So we just do nothing, and then return, yeah? Because computer do nothing, yeah? It doesn't need to do anything, right? So another way is the if bar dot x is smaller than apple dot x, apple x, yeah? Apple x. Right? So the apple is on the right hand side. Right? So we can just move right, right? Simple as that, right? Yeah? hairs move left. Yeah, that's the simple logic without without considering if we can actually wrap our ball from the other side, right? Okay, so can we try that? Look, does it work? Okay, now, yeah, you see? Okay, make sense? Yeah, it's actually doing that, right?
Yeah.
Yeah, look, but you will go for the look. The apple is the ball is here. The apple is here. It will actually move right instead of move left because move left is the faster, right? But it thinks okay because it's on the right hand side.
11. Yeah,
Okay, because it's too far, yeah?
Yeah.
It's too far to catch it, right? This is the thing, right? Because if the apple is here, okay, so let's say if apple is at least 4-2, right? And then we are on the left. So what will happen? It takes 1, 2, 3, 4 to go to the right, but at that time the apple has fallen on the ground. It doesn't catch it in time, right? So that's why this algorithm works sometimes, but it's not super smart, right? Yeah, it's not super smart. So we can.
That's why I lost.
That's why it loses. But that's the basic version, right? That's the basic version. So first of all, we need to define the cost of moving left and cost of moving right, right? Right. So how do we check if the cost of moving left and cost of moving right? So first of all, we say cost. So look, if about, so let's say instead of let's just do this, okay? Cost of moving right. Cost of moving right is apple x minus bow x, right? Yeah, it's on the right hand side. But again, we have one more choice of moving left. So cost of moving right. Okay, again left. Cost of moving left. You can still move left equals what? So let's see this let's do this a little bit here. So apple is here, right? Apple is here, and I'm here. The ball is here. So you can move left, move right. The cost will be, the distance will be this minus this, right? But you can also move to the other hand side, right? Yeah. And what's the cost? It's 5 plus. So it's 5 plus what? Plus these. So how do we get this? So what's the mathematics? Look, how do we calculate the mathematics? So the distance is equals this distance, right? Equals distance plus this distance, yeah? Alright? Yeah? So what is it equal? The overall, this is 5. This is 5, right? 5 pixels, right? Is it 5 pixels?
Yeah.
5 pixels. So overall 5 pixels. And we want to calculate the distance between this and this. Right? So it's actually 5 minus this bit is 5 minus this. This bit is this, right? So it's 5 minus apple. Yeah? Minus apple. 5 minus apple is this, actually this bit, yeah? Yeah? Because look, this is 5 minus apple is this bit plus this, yeah? So plus the ball, right? The position, yeah? So that's the simple math, yeah? So it's 5 minus apple plus, okay? So it's 5 minus apple plus ball x, okay? Yeah? I could possibly do this as again ball x equals ball dot x, okay? Just to save the variable, so we can just use this instead of calling this method to save us time, okay? Okay. This is the cost of moving left and cost moving right. Yeah, exactly. Okay, so now look, this is cost of moving left, cost of moving right. But okay, so actually look, because this is position, we have to put it here, right? Yeah, because this is the position of doing that. But on the other hand side, on the other hand side, when the apple is smaller than ball x, so it's the opposite. So it so if apple is here and your control is here, yeah, the cost of moving left is this is simple, yeah. You just calculate the difference, yeah. Okay, so cost of moving left equals what? Equals the bar x minus apple x, right? Yeah. Look, this now bar here is bar. Here is what? What happened to my input? Just a second. Bar is now bigger than apple x, yeah? Right? On the right hand side, okay? And then now cost of moving right equals what? So it's the same, yeah? It's actually the same, yeah? So look, if cost of moving right is this bit plus this bit, okay? Okay, this is the whole pixel, yeah? So it's 5 minus this plus this, yeah? 5 minus bar. So 5 minus bar plus apple, yeah? Okay, so there are two distances. Okay, now what should we do? We have calculated two variables, moving the cost of moving right and the cost of moving left. And what we prefer, which way? Which way we prefer? Look, there are two situations. Basically, this is just to check which the position if the apple is on the right hand side or on the left hand side of the bar, right? Of the bar. And now based on this, I have computed two cost. One, the cost of moving left, and the cost of moving right. So which one we should choose? Choose which one, the bigger one or smaller one? Yeah, of course, the smaller one, the bigger, yeah, the better, yeah. So if cost of moving left is smaller than cost of moving right, right? Then we move left, right? Alright? Right? Alright? Else we can just move right, right? Okay, there might be a situation the moving left equals to moving right, then we don't care, right? Yeah? Okay, let's try this to see if it works, okay? So you'll be super clever. Look, it turns on the other side, right? You see? Yeah?
But go very slow.
Don't worry, you will be moving, the apple will be moving faster and faster. Right? If the
I
apple.
guess we'll go faster.
Okay, so let's wait a little bit. Look, now it takes the shortcut. Yeah, instead of going around all the way. So you will never die. So this version you will never die. You will never game over, right? Okay, look. Because it's always picking the shortest. Yeah, shortest. Alright? Wow. So I ideally, eventually it'll be like whew. Yeah. So look, it's getting faster and faster. Wow, the human being cannot make such cannot react so fast. Yeah? Look, how can you play like that? Yeah? The computer will never.
It's so funny.
Yeah. The computer will never make a mistake, right? So, yeah. You see? So do you get it? Look, this is the computer play, the artificial intelligence, the basic is called decision rules. Yeah, decision rules. So basically, it's based on checking a few conditions and pick the best. Right. So what's the cost of moving left? What's the cost of moving right? Okay. Now, moving left is the cost is smaller, the distance smaller, quicker. Yeah? Now we prefer the moving left. Otherwise, prefer moving right. Right. Alright. And at the beginning, we implement a very basic one, which is just check. Okay, if apple is on the right hand side, we move to the right. If apple is on the left hand side, we move to the left. If apple is right above us, we do nothing. This is decision rule. Yeah. So artificial intelligence. You know what's artificial intelligence? The intelligence of computer. Yeah, how the computer thinks. Okay, you see? Yeah. Okay, makes sense. Okay, the last step is we just put this. Yeah, we just download it, and then let's see if we download it here. Download. Okay, download, and then download it. Okay, and then let's copy it to Microbit.
complete.
Yeah.
20, 33, 37, 50, 53, 66, 70, 88.
Okay. Yeah, it's now that. Look. Yeah, let's go. Yeah, you see? The computer will play. Yeah. Okay?
I was trying to play it and Daddy downloaded the wrong one.
Okay. Yeah, okay. So that's the basic, that's it for today, okay? So what have you learned today?
About how to make computer play.
Yeah, artificial intelligence, yeah? Artificial intelligence, AI, yeah? Decision rules. This is the basic, one the most simplest.
Hey, the computer just lost.
How did you do that? You never, how?
Look at this.
How?
Wait.
I think.
Let me go.
Oh yeah. I know. Why? Because I haven't turned off the control. So look, you can still press the control, right? When the computer play. So you just intentionally make the computer lose, right? Yeah. Then computer will lose. Okay. That's it for today. Say bye bye to people. Bye bye. Ryan.
Wait.
Ryan,
The
bye bye.
computer's making it worse.
Okay. Bye bye.
Bye.